Hello, everyone. A warm welcome to you who tune in into this session. My name is Robert, and I'm a solution engineer focused in networking and security at VMware. I'm working with customers from financial services and telecommunication industry in Singapore. I want to share with you about how to supercharge the Ingress controller for multi-cluster Kubernetes and OpenShift setup. Before I jump into the main menu, there are some disclaimer here. This presentation is about sharing my experience and what I observe when I work with my enterprise customers. Ingress Controller is provided by NSX Advanced Load Balancer platform. So prior knowledge about the NSX Advanced Load Balancer platform is encouraged. So check out the other sessions about NSX Advanced Load Balancer platform. So here are the three things that I'm going to talk about. I'm going to share a view from my observation on how enterprise customer runs Kubernetes or OpenShift cluster, as well as the supporting infrastructure. What are the challenges to that customer, and how can we address the challenges? So let's look into it. This is the typical view of the container platform in the enterprise. There are multiple Kubernetes clusters in the enterprise environment. The common scenario is they have a single cluster for each data center. The cluster has Ingress Controller installed in the cluster itself. Either it is in a dedicated nodes or in the shared nodes. The Kubernetes cluster is typically interfaced with an external load balancer to provide layer 4 load balancer, GSLB, as well as DNS, IPAM, and web application firewall services. These appliances are used to distribute and secure the client traffic into the application running inside the Kubernetes cluster. The relationship between the GSLB, layer 4 load balancer, DNS, IPAM, and web application firewall are discrete. Typically, they are set up in inline mode. So meaning that each box will intercept the client traffic. And lastly, these boxes are here and managed by different teams. There are three teams involved here. The platform team usually manage the container platform. The second team is the network team, or sometimes it is being called application delivery network team, which manage the load balancer and then GSLB, DNS, IPAM, and web application firewall. The third team is the application team itself, who deploy the application manifest into the Kubernetes cluster. There are three challenges when it comes to operate the infrastructure around Kubernetes setup. One is visibility, second is partial automation, and the challenges from operational perspective. So let's go deep dive into the details. The first challenge is visibility. What do I mean by visibility? So if you look from the perspective of external load balancer, it does the health monitor into the Ingress controller. This can be a TCP-based or HTTP-based probes into the Ingress controller itself. So when the pod goes down, the virtual IP in the Ingress controller will still up because it's simply the Ingress controller still alive. And this will cause the traffic black holing. So it brings me into the next point, which is how to redirect the client traffic. Because now the client traffic is being routed towards the layer 4 load balancer, and then is being routed to Ingress controller, but the Ingress controller doesn't know where to route the traffic. So this is what the traffic black holing that I mean. So it brings me into the second challenge, which is a partial automation. So related with the external load balancer, the visibility challenge, the external load balancer has to be configured manually in order to not route the traffic into the Ingress controller because the pods are simply failed. So this is necessary to avoid the traffic black holing. Some of my customers shared to me that wildcard DNS raised a security concerns because basically you can query any FQDN under a particular subdomain and you will get a reply. And FQDN is specified in the Ingress manifest. So when the application team deploy an Ingress, the Ingress controller will create the policy based on the specified host value inside the Ingress definition. This is important to route the traffic into the specific service. However, this FQDN has to be manually configured in the corporate DNS in order to route the client traffic from external into the application hosted in the Kubernetes cluster. The third challenge is from operational perspective. So basically, there are three teams involved here: the apps team, the network team, and then the platform team. So imagine if the apps team deploy the same set of application in two different clusters. Let's say it is a West cluster and East cluster. The default traffic distribution, let's say, is 50-50, 50% goes to West cluster, 50% goes to East cluster. In some cases, the apps team wants to change this distribution, let's say, into 80 and 20. So 80% goes into the West cluster and 20% goes into the East cluster. Typically, this is to be done when they want to do some kind of maintenance in the East cluster. So they want to take some of the nodes to do maintenance, patching, and all that. So the apps team need to raise a request to the network team to basically change this distribution. Second, it is rare that enterprise only runs a single set of container platform like this. Typically, they run multiple set of this because they have like SIT, UAT, and then development environment. They have multiple sets Kubernetes cluster for this. And this will increase the amount of external load balancer as well as the Ingress controller. So operation like updating the SSL certificate or maintaining the life cycle of the external load balancer is challenging. Last thing is stitching the DNS, GSLB, and web application firewall requires proper planning and discrete maintenance process. The load balancer administrator needs to configure each system individually, but they have to work together. So let alone troubleshooting of the application itself. I forget to mention about how to scale the Ingress controller. In the Kubernetes cluster, you can scale out the application pod as much as you want because the platform is flexible. You can just scale out and scale in the application pod. But how to scale out and scale in the Ingress controller? Because in order to scale out the Ingress controller, you need to add more nodes to it in order for the Ingress to scale out. So this is another challenge. So how can we do better? How can we supercharge the Ingress controller itself? So we can move from this view into this new view. So this is how we supercharge the Ingress controller. We take out the Ingress controller from the Kubernetes cluster and running it inside the modern application service platform by NSX Advanced Load Balancer. We integrate GSLB, DNS, IPAM, web application firewall, and layer 4 load balancer and Ingress controller in a single platform to provide a comprehensive application services. With this integrated solution, it simplifies the operation task of application delivery network or the network team and reduce the overhead with automation. Ingress controller is located in the strategic place between the client and the application pod itself. Because simply the Ingress controller is terminating the client traffic. So telemetry such as client round trip time, the server round trip time, how much time does it take for the application to respond back into the client, and then what is the time taken to fulfill the client request. All of these are important metrics and valuable to be tracked, and it is valuable as well to measure the user experience. So observability in terms of client traffic is built into the Ingress controller. And lastly, you can scale out the Ingress as and when, like you scaling out the application pod itself. So NSX Advanced Load Balancer has the elasticity characteristic and able to scale out the virtual service to be handled by multiple data plane components. The scale-in, scale-out architecture allows the Ingress controller to be flexible and match with the application demand. So this is the three things on how NSX Advanced Load Balancer is able to supercharge the Ingress controller. The first one is the full visibility. Second one is it gives you the complete automation, and it is operationally simple. In terms of visibility, NSX Advanced Load Balancer has health monitor directly into the application pod. So this allows the failure detection of the application pod and allow better traffic distribution decision. So when the health monitor to a particular pod failed, the controller will mark that pod as down. So the client traffic will not be routed into that specific pod. The client traffic always routed to the healthy pod. The status of the virtual service is also tracked by the NSX Advanced Load Balancer controller platform. The Ingress controller is aware of the health of the application pod. This is the second benefit of NSX Advanced Load Balancer, which is the complete automation. So the Ingress controller is aware of the health of the application pod. When all pods in the deployment fail due to a certain reason, the virtual service is marked as down. It will trigger the chain reaction into the GSLB, the DNS, for example, taking out the DNS record out from the DNS server so that it won't resolve to that particular virtual service IP. NSX Advanced Load Balancer configures the DNS record based on the host value in the corporate DNS service. So when the apps team deploy an Ingress, the DNS record will be created automatically. Ingress definition with a specific label and annotation will also configure GSLB services and policy automatically. So this brings me into the third point, which is streamlining the operation. The configuration of objects for NSX Advanced Load Balancer is defined in the Kubernetes manifest. It streamlines the operation of configuration in the load balancer itself. So when developer configure the Ingress, it will be configured, it will be realized inside the NSX Advanced Load Balancer as a virtual service. It will be realized as a GSLB service, and it will be configured inside the corporate DNS itself. Second, it simplify the Ingress controller architecture. So in summary, NSX Advanced Load Balancer gives you the integrated solution for application delivery network, including the Ingress controller. So if you have questions or feedback, you can email me. I also write a personal blogs at alvianus.net. And thank you so much for your attention, and we'll see you in other session.